Good day, Bayaos. Today, let us learn another relative problem involving fluid mechanics and hydraulics. Chapter 3, Total Hydrostatic Force on Surfaces. But before jumping in, let's have some deeper understanding what is buoyancy, Archimedes' principle. Buoyancy is an upward force exerted by a fluid on partially or fully immersed object. It's equal to the weight of the fluid displaced by the object, and it is the ability or tendency of an object to float or rise in a fluid.
Let's have some problems. The upper end of a hydrometer has a 2.59 mm diameter stem and weighs 0.0234 Newton. Determine the differences between the depths to which it will float in its oil that has a specific gravity of 0.78 and alcohol that has a 0.821 specific gravity.
We are tasked to find the following: the depth of float of the hydrometer in alcohol and the depth of float of the hydrometer in oil. Bring out your pen and paper and together let's solve this problem.
Diagram showing the submerged or immersed hydrometer in alcohol and in oil. We're going to find the differences of the depth of the hydrometer in oil and in alcohol. Given the hydrometer's weight 0.0234 Newton and the stem rod's diameter 2.59 mm, the specific gravity of oil and alcohol. First, we are given the hydrometer's weight, the specific weight, and the specific gravity of alcohol. We are now going to find the depth of float of the hydrometer and alcohol. Using the buoyancy formula, that is according to the definition, is equivalent to the weight of the object, where the buoyant force itself is equal to the specific weight of the liquid multiplied to the volume displaced. Substituting all the given to the formula, we acquire a volume displaced of hydrometer in alcohol 2,905 cubic millimeter. Next, we are given the following, and we are now going to find the depth of float of the hydrometer and oil. Again, using the buoyancy force formula, substituting all this given to the formula, we now acquire the volume displaced of a hydrometer in oil, that is 3,058 cubic millimeters.
Moving on, let's proceed. We are given the following: the displaced volume of alcohol and oil 2.905 cubic millimeter and 3,058 cubic millimeter. Let us get and solve the difference the both, and we acquire the volume of 153 cubic millimeter cube. That is the total volume of the cylinder. Upon acquiring the value of the total volume of the cylinder, let us now proceed in getting the height difference of the hydrometer submerged in alcohol, then the hydrometer submerged in oil. We have the hydrometer weight 0.0234 Newton, the stem rod's diameter 2.59 mm, and the specific gravity of oil and alcohol, and the volume we acquire the cylinder, that is 153 cubic millimeter. Plugging in all this to the formula, we can now be able to get the height difference, that is 29.04 millimeters. That is the height difference between the hydrometer submerged in alcohol and that of the oil. In conclusion, the difference of the depth of the hydrometer in oil and alcohol is 153 cubic millimeters. The distance of the submerged hydrometer from alcohol to oil is about 200 29.04 millimeter. Find more about these videos and problems in Fundamentals of Fluid Mechanics 3rd edition, Basavilla, Problems 3-90. That's all for today, Bayaos. Thanks for watching. At least height. Up next, Chapter 4, Relative Equilibrium of Liquids.